In this video, we're going to learn how to do definite integration by substitution. Before we come to definite integration, first of all, let's have a quick review on how to do indefinite integration by substitution. For this indefinite integral, we can first of all let this 3x minus 1 be u. And then we should differentiate both sides so that we can get du is equal to 3dx. Now I can rewrite 3x minus 1 as u and then dx as 1/3 du. And then this can be integrated in this way. And we must not forget to substitute 3x minus 1 back into u, so that this is the final result and it is in terms of x but not u. And we should remember that there is another way to do substitution without letting u, by applying the properties of differential. By rewriting the differential like this, now I have changed the variable from x to 3x minus 1 without letting u. And then in this way, this can be integrated like this. If you can understand how to do indefinite integration by substitution, now we can proceed to talk about definite integration. In this definite integral, we have the lower limit and the upper limit, and these limits are on the variable x. So when we have a new variable u, we should consider a new set of limits on the variable u. In this case, if we let u be 3x minus 1, we should consider that when x is equal to 1, u is equal to 2, and when x is equal to 3, u is equal to 8. And then when we do the substitution, we should rewrite the limits as well, so that these limits are now on the variable u. Now this definite integral can be evaluated easily. Please note that there is no need to substitute 3x minus 1 back into u, because we can already substitute these new limits into u to evaluate the definite integral like this. And the other way to do the substitution is to apply the property of differential without letting a new variable u. In this case, we have changed the variable from x to 3x minus 1 without letting a new variable u. Our convention is that if we do not have a new variable, then we should not change the limit in the process of substitution. Even though we have changed the variable, we do not change the limit if there is no new variable u. We can continue to evaluate the definite integral, and then in this step, we should substitute 3 and 1 into the variable x, so that we can get the exact same result. We can see that there are two ways to do substitutions. One is to define a new variable, and the other way is not to define a new variable. However, we can usually combine these two methods to do definite integration by substitution. Let's take a look at the following examples and see how we can mix the two methods. In this example, we can first of all apply properties of differential to put x into dx, so that I can get dx squared times half. Now we know that we can integrate this expression because we both have x squared here. In this way, before we do integration, we can first of all rewrite x squared with u. And we should also rewrite the limits, so that this expression can be somehow simplified. We can continue to do integration, and then in this step, we should substitute 2 and 1 into the new variable u. And this is the final result of this definite integration. Next, we can take a look at this example. In this definite integral, again, I can first of all put x into dx so that I can get half dx squared. And then we want to change the variable from x squared to 2x squared plus 7, so we should further divide the integral by 2. Please note that in these steps, we do not change the limits, because there is no new variable. But after this step, we can define a new variable u to let u be 2x squared plus 7. So that this definite integral is simplified, and then in this way we should rewrite the limits. Afterwards, the definite integral can be evaluated like this. Finally, let's take a look at this example. In this definite integral, putting x into dx to make it half dx squared will do us nothing good because there is no x squared. Instead, in this question, we should directly let 3x minus 1 be u, so that du is equal to 3 dx, and when x is equal to 2, u is equal to 5, and when x is equal to 5, u is equal to 14. And then we should do the substitution in this way. After the substitution, now this expression can be expanded in this way. and so it can be integrated like this. This is how we can do definite integration by substitution. Unlike indefinite integration, for definite integration, there is no need to do backward substitution in order to get the final result.